So, hello everyone, and welcome to today's quantum leadership session hosted by the Quantum Business Network and by me. I'm Mila Koronovska, the marketing and event manager at QBN, and we are really thrilled to have you here for this exciting session focused on the quantum technologies in defense and space, an area that is actually rapidly transforming industries and advancing critical capabilities. Um, So, yeah, for those of you who may be new to QBN, the quantum leadership sessions are part of an ongoing effort. Um, yeah, sorry about that. So for those of you who may be new to QBN, the quantum leadership sessions are part of our ongoing effort to provide a platform for our members to showcase their innovative work, share breakthroughs, and really engage with the wider quantum community. So it is a unique opportunity to see firsthand how QBN members are really leading the way in applying quantum technologies to real-world challenges. So today we have a fantastic lineup of distinguished speakers from across the quantum ecosystem, each one of them really bringing an invaluable expertise to the table. So we have Alexandra Pinto from Xairos Systems, who will be discussing quantum time transfer using entangled photons for resilient PNT applications. Next, we have Laurent Guiraud from Colibri TD, who will be sharing insights on working with the French Defense Innovation Agency and the challenges and opportunities in this space. And afterwards, we'll have Matt Himsworth from Aquark Technologies, who will be diving into the opportunities and challenges in sensing and timing with cold atoms. Next, we'll have Muthu Vetrivelan from Artificial Brain, who will explore the role of quantum technologies in defense and space. And last but not least, we will have Tommaso Occhipinti from QTI, who will give us an overview of quantum communications for defense and space. And I will be moderating this session, as already mentioned earlier. So each speaker will provide a deep dive into the area of expertise, and after each talk, we'll have a 5-minute, 5-minute floor for a brief Q&A. So please feel free to submit your questions via the Zoom chat or also on YouTube, as we are live there as well. And we would like this session to be as interactive as possible, really. So yeah, this is a brief overview of the agenda. I will start by quickly introducing QBN and giving a brief overview of our mission. Then we'll move to the speaker talks, hearing from our amazing speakers, each presenting their slides and expertise. And again, we'll have a 5 minutes for Q&A. So I encourage you to really think of questions during the talks and post them in the chat. Just a quick glimpse over the next upcoming QLS quantum leadership sessions. So these are happening, the two of them are happening in May. And then also we have some planned for the autumn. And if you're really interested in them, please visit our website to find out more about them. And without further ado, I would like to start introducing QBN. So QBN is the leading network, industry network for quantum technologies, founded in 2020, currently representing more than 100 international members, so including startups, SMEs, global players, and research organizations, all working within the quantum computing, sensing, communication, and cybersecurity. Our mission is really to position Europe and the Asia-Pacific region as leaders in quantum technologies, driving economic growth, ensuring security, and advancing real-world applications like quantum computing, sensing, and the quantum internet. In addition, QBN offers a tailored consultancy services to help enterprises, governments, and investors become quantum ready. And we also support startups by providing guidance on scaling, commercialization, and accessing strategic investments. So here on this slide, you would see that our services are divided in two main pillars. The first one is Global Innovation Network, and the second one is Business Innovation Services. So the Global Innovation Network focuses on topics such as policies, ecosystems and entrepreneurship, individual support, knowledge exchange and technological transfer and collaboration, and also really the provision of access to market, finance and international business activities. The second pillar, business and innovation services, touches upon topics such as investor, end user industries, quantum industry, startups, and investors. So in one of the next slides, you have a further breakdown of each of these pillars. But before that, I would like to present our international members. Over the past few years, QBN has really grown rapidly. Now counting more than 100 members across various industries, from really component suppliers to full stack quantum technology providers, basically covering the full value chain. So our members collaborate on industry challenges. They try to solve them, they explore new business models, and really accelerate the path from research to market-ready quantum solutions. So by joining QBN, companies really gain direct access to a powerful network of experts and also decision makers, helping them stay ahead really in the fast moving quantum landscape. So again, I encourage you to visit our website to find out more information about our members and how you can become a member as well. QBN membership is really international, open to corporations, research institutions, and organizations working within the quantum technologies and its value chains. And also being part of QBN really means gaining access to a global community of industry leaders, researchers, investors, and others, all working together to drive really commercialization and adoption of quantum technologies. So now moving to the pillars once again, I would like to briefly outline that through matchmaking, we connect companies with the right collaboration and partnership partners within the quantum value chain. And we advocate for quantum technologies, guiding policy development and creating supportive environment through lobbying. With access to both private and public funding, we also leverage our deep tech investors and funding expertise to support companies' projects. And we also have 5 technical working groups, which really provide a platform for collaboration, knowledge exchange, and market insights across the whole value chain. QBN also helps really companies to increase their visibility by promoting their product launches. We also offer the Business Forum, which on itself offers professional knowledge and experience on critical topics, really like intellectual property, sales, marketing, and investment. And finally, we also provide access to our contact hub and archive, which is really valuable because it contains valuable and insightful industry reports, videos, and presentations to really keep people informed on quantum topics. The next pillar is business and innovation services. Basically, our business strategy workshops help companies to unlock their business potential by addressing challenges and building on strengths to scale their operations. We also offer technical due diligence and investment advisory, aligning companies' strategy with the latest quantum trends and technologies. QBN also supports businesses use and case development, helping end users leverage quantum technologies in line with their strategy. QBN enhances decision makers' awareness about quantum developments by developing and implementing effective communication strategies. And we help also our members to explore new markets and expand internationally with lean strategies and really strong business support. But again, more information can be found on our website. Here briefly, I would like to introduce the Quantum Incubator for end user enterprises, which really empowers end user enterprises with resources, mentorship, and strategic guidance needed to thrive in this quantum era and basically achieve their business objectives. So in doing so, we offer a fast onboarding and we call this a fast track to quantum readiness package, which includes also the free enterprise membership for 1 year and also a 25% of discount on the QBN membership within the first year. So really a rare opportunity you cannot miss. For more information, again, really go on the website and you will be able to find more. Just very briefly on QBN achievements. So this slide really represents the great success QBN has managed to achieve in the last few years by building a strong network of, again, more than 100 international members. We really held global conferences and events, initiated endless partnerships, and also managed to arrange more than 200 million euro in private and public funding. So also QBN has really successfully expanded its global presence, reaching over 20K online followers and taking a strong impact both digitally and in person worldwide. So we have also established really close and strong ties with governments at both European and international levels. So yeah, in terms of a future-proof strategy, I would highlight lobbying, and here we are really aiming to develop a strategy for Europe and Germany on a political basis, where we want to influence strategies nationally and internationally to impact quantum policies and overall really drive the quantum ecosystem in the long term. This is a brief look at the QBN team, which really combines a strong background and deep tech and quantum technologies with interest in company building, innovation management, and global cluster management. We support our valued members really with our expertise on those points in guiding them towards growth acceleration and tech development. I'm glad to really present very briefly some news from the network. So here we welcome our recent new members. So yeah, we really invite you to join us in we're giving them a warm welcome. And also here, this is a brief overview of the events where QBN will be present and where you can meet us and connect with us. Out of all of the events, I would like to really highlight two of them. So the GTEx, where QBN is a strategic partner. GTEx is also Europe's largest technological event, where we will also have a booth and also we'll host an investor briefing. Important to note here is really the 20% discount on booths, which we grant to QBN members, being a strategic partner. And also the second event is really the World of Quantum, where one more time, QBN will have its QBN pavilion, having ensured a prime location, high visibility, and an inviting lounge area, really providing the ideal platform for meaningful collaborations. On June 25th, we'll also host the QBN VIP networking reception, which will really take place as an exclusive invite-only rooftop barbecue and drink event. Finally, here is a list of the funding calls, but I again warmly encourage you to visit our website where you will be able to find out more about them. And having said all that, I would really like to invite everyone to join forces with QBN in the common mission of really building a resilient and sustainable quantum economy together. Stay up to date with our latest news on quantum news, job openings, industry news, and events by really following us on LinkedIn, YouTube, and also you can subscribe to our newsletter. And you can also sign up on our website to follow all of these news. So thank you very much for your attention. And really, I would like to now move on to the agenda and to the speakers. Once again, you can write your questions in the Q&A box and we'll make sure to answer them. So without further delay, I would like to invite Alexandra Pinto from Xairos, who will be speaking on quantum time transfer using entangled photons for resilient PNT application. And Alexandra, the floor is yours.
That's great, super. Then I will just share my screen.
Sure.
I just keep my video off just to save some bandwidth. Just 1 second. Can you see my screen now?
Not yet. Oh, I think that Alexandra is no longer in the call, so maybe we can move on with the next speaker while she rejoins us, which is Laurent.
Okay, can you
Thank
hear
you.
me?
Yes, and we can
Can you
see
see
your
my
screen.
screen?
Yes.
Okay, so it's perfect. So I won't be long anyway, but I want to try to make to the point. So first, I'm not sure everyone knows who are we on the YouTube channel. So basically, we are Colibri, TD, like the hummingbird in English, and we are quantum computing software platform. So we develop algorithm and software to specific use case. So no hardware, we are agnostic to hardware, and we work with the current existing quantum computer in the near-scale, near intermediate scale quantum. So that's, and next slide. The team, briefly. So Colibri has been founded in July 2019 by myself and Asen. So I'm the technical guy. I have a PhD in physics for some time already. And we have Asen, which is more the business person into the duo here. We are supported by an advisory board that we are currently expanding, if you're interested. So right now we have Dr. Christophe Bianchi, which is a next ANSYS member, which are specialized in simulation software. And you will see that's specifically what we are working in. But we are not alone. We currently have 16 experts in quantum computing, rather 80% PhD in physics or mathematics, and we do have a scientific council, and we are expanding our R&D team and the team in a more generic way. So what do we do exactly at Colibri every day? That's really important. So when we started the R&D, we identified a specific topic that was across every industries, which is technically speaking, solving partial differential equations. So I'm not sure everyone is engineers here on the call, but basically what are partial differential equations? They're everywhere. If you want to simulate fluids into a tube, you have to use partial differential equations. If you want to simulate the heartbeats, the fluids in your body, that's partial differential equation. If you want to simulate thermal transfer in a nuclear power plant, that's partial differential equation. If you want to simulate some risk calculation equations in finance, that's partial differential equation. They are everywhere. And they are very difficult to solve because it tends to, you need more parameters to really simulate a process. And the more parameters you have, it's exponentially complex. So we thought quantum can help. But in order to do that and to solve that problem, in order to bring value to the customer, you first need to develop the algorithm. As many of you knows in quantum, there's not that many algorithms available, especially with existing computers. So 80% of our work is basically developing algorithm, developing a unique IP. Then we have a second pillar that we develop. It's basically if you have to deploy on any machine, you can't use every single framework out there. And that's why we develop a framework of our own, which helps us to be agnostic to hardware to deploy. And the third aspect of our strategy is to have as many partnerships as we can with hardware vendors on existing computers. That's really what we do every day, providing a platform called Quick that solve simulation problem. And that's the example of customers or project we are working on, defense, startups, combustion use case, fluid dynamic use case, and some specific microprocessor, microchips use cases. That's what we currently working. We have strong partnerships with hardware vendors, the IBM, the AWS, but also in Germany, Electron, in France, Cobly and others. And we also have academic links. But we want to expand all these aspects of our engagement today. So let's go into what we did for the Agence Innovation Défense in France. So what is first Agence Innovation Défense? It's a very innovative arm of DGA, which is the Direction Générale de l'Armement. It's a defense agency in France that basically help startup SMEs to build projects that could be funded through subvention, through subsidies, in order to bring some dual innovation point. So it's important to insist in the dual aspect of the things we need to go through RAPID. So RAPID is just the abbreviation Régime d'appui à l'innovation duale, which is dual use innovation support program. But RAPID is also meaning fast, which is basically it's something where from you the time you submit your project to the time you get the money, it's really short. It should be within 1 year, which is pretty short overall. I mean, let's be clear. When you talk about this kind of project at any level, it always takes time. So that's pretty short. So it's reasonably well funded. We talk about hundreds of thousands of K or millions euro. So it's basically, and usually you have to go through a partnership program. So that's really a very, I mean, I don't know if it exists in other European countries, but basically it's a very, let's say, easy with quotes because nothing is easy, but it's a rapid, simple, straightforward program with a lightweight process to get funded and to get some subsidy to move forward on key area. That's really what you have. And if you know of any other program in Europe, would be interested. I do suspect that every country has its own, wants to have his own country partners. Not like, I'm not sure you can switch between partners, but I mean, I don't know. So what we really at Colibri, we focus on many areas: industrial simulation, quantum for good, climate simulation, tsunami simulation, and so on. But there's a focus on aerospace and defense also, because that's, I mean, as you may know, defense has some money and they want to spend in some sovereign technology, and quantum is part of it. And not only every kind of country in Europe has some kind of program for hardware, but they also want to invest in some software and application level. That's what we did, and we decided to go for combustion. There's many other topics we could go, but right now we decided to go for simulation of combustions using a system of nonlinear partial differential equations. For the less engineers, it's the mathematical framework I mentioned that basically we saw using quantum technologies. So that's really the focus we had, and that's really what we defined for our project. So the VulQain, we call it VulQain. So I don't know how it's from the Greek god of fire. VulQain basically is a term we said for combustion. Makes sense. So basically, it's the project management is overall followed by the Direction Générale de l'Armement and the ID, Agence Innovation Défense. By the way, there's nothing secret here because it's rapid or by default public projects, so therefore they have to be public announcement. So that's nothing secret. We have even a press release of it. So no secret here, not to be worried about censorship here of my slides. So to go back, we basically did this project with two key partners, including us, Colibri, which is a leader. We had Onera, which is a French aerospace lab. It's really important. I think it's the equivalent of the DLR in Germany. So basically what is important here to understand is that we are not supposed at Colibri to have a team of experts in all the technology I mentioned: fluid dynamics, combustions, finance, risk estimations, thermal transfer, and so on. So we do bring for project partners that can bring this expertise. Onera is the one. And then when we do the pipeline of development of our projects, before we launch on real hardware, we mostly use simulators of quantum systems. And here, in this case, for this project, we use the Eviden Captiva platform, which is basically a quantum simulator. That's the three parties project we propose, and the rule of the AID Rapid project give some percentage of subsidies to every partner depending on their nature. A startup get more subsidies than an industry player like Atos, and less money to public kind of entities like Onera. So that's really the philosophy of this kind of project, where usually you don't go alone, you have to be at least two and maybe eventually three. So what was the goal of our work is basically how did we work with the different partners? I briefly mentioned what was the approach, but basically Onera was giving us the combustion model, basically the mathematical equations you need to solve a combustion flame. They also give us how they did it today, so we could compare. And also give us the expertise to the end user that was able to provide and use what we were providing as a platform. On our side, we were using our platform, which is first based on HDES, which is hybrid differential equation solver. It's a multi-physics equation solver, and MPQP, which is our deployment tool to machines. And we were doing the hybrid post-processing and result synthesis. That's what our core role. And then we were running that on the Captiva quantum emulator from Eviden. Really simple, really straightforward. Everyone has a role, was clearly identified. That was a 2 years project. So we basically did what we had to do in the 2 years framework. I forgot to mention the duration, 2 years, 3 partners. And basically we were on time, on budget, and we did deliver what we said we were delivering. That's really important for us at Colibri every time we do a project, to really be respectful of the timing and the deliverables that were supposed to come. Even in a specific area like quantum, where you could think that in the current times, you cannot guarantee anything, but you can at least understand what is you want to achieve it. That's really the opportunity. And to extend beyond what we did with AIDE, it's really the way we do other projects also. Really clear on what is deliverable and very realistic on what exists today in quantum and what will exist within the next year. So that's really important for us. So to be really, I mean, for the most technical in the audience, what did we do exactly? To be concrete, basically we did 1D laminar flame for 2 species. What does it mean? So 1D. First, the flame is 1D, not 2D. And also there was 2 species. Combustion is based on chemical reaction. There was only 2 species. You might say, if you are expert, that it's really simple. But first, it's not that simple classically. And it has to be proven that you can model before simulating. You can model in a quantum way a specific formula. So every project we have, most customers comes with mathematical frameworks. You have the first step is to prove that you can have a quantum algorithm that can solve this, basically this mathematical problem, and then you simulate, and then you run on real hardware. That's the different steps. So that's why we choose a very simple product, like we did a 1D material deformation for another use case, in order to prove that you have the possibility, the capabilities to model in a quantum way. That's a very specific way that we do for every project. So really simple, but not that simple. And the fact that we were able to model this flame in quantum was already a big achievement. So what we did at the end of the day with the Agence Innovation Défense, we developed a novel model. We solved the simplified but challenging 1D. And as I said at the beginning, if you followed the presentation, we are working with current NISQ devices. So anything we do, any model we do, has to take into account the noise of the different hardware, even if it's a simple noise model to start with. So we also started to study additional dimensions. Time, for example, time is a dimension. I mean, when we simulate the flame, the time was not there as a 1D, but you can add 1D plus time. We also looked at the complexity because everything we do, we need to make sure customers understand what would be the benefit when the computing machine, quantum computing will scale. It's always mandatory to give a perspective. Today we did it with 50 qubits. What would happen if we have 100? What would happen if we have 200? And we also build the overall UX, but the UX is an IT project. But nothing complex. That's all I wanted to present. I'm hoping I'm not too fast. But basically, really what we want to see also is the AIDE, which is a French governmental organization, really trusted us on that project, really gave us the expertise. We worked with really great partners, and we want that to repeat with different projects. There's many things to be done. We also want industries to be involved and so on. That's really, there's a methodology to address, and that would help develop new platform, new algorithm with existing hardware, which is really important. We have to start now doing real project for real application in order to prove to the industry that quantum is now rather than in 10 years. So that was what I wanted to say. Thanks for listening.
Thank you, Laurent, very much for this insightful presentation. Now we can open the floor for a quick 5-minute Q&A session. So yeah, I would like to invite once again everyone to submit their questions in the Zoom chat or in the YouTube comment section, and we'll try to answer as many of them as possible. So I see no questions in the Zoom. Does anyone, maybe from our panelists, have a question? I don't see any hands raised. Haysam?
Yeah, thank you very much for the great talk. I have one question. So typically in defense, let's say the procurement is something which is very complex and a bit difficult, and also to work, let's say, or collaborate with the defense sector typically is complex. And you mentioned now for this program, it was quite easy. So can you comment a little bit on that? Maybe what are the lessons learned that we can take for other programs? So taking, for example, the procurement time and so on.
So the rapid, like I said, this support for innovation is really has to really be made to compensate from this complex procurement system. Definitely, that was really a role of this program to compensate. But yet, normal procurement is still complex. But I would say not only in defense, in most industries, it's complex. In these new technologies, you have to go through many hurdles. That's why this kind of program has been, and I think its quantum is pretty. We should not only work with this kind of program, but frankly, when you are early stage startup, they are really good. And if we could have more of that, and go into other projects across Europe, that would be great.
Yeah, thank you very much.
Merci. Thank you.
Yeah, thank you, Laurent, once again for this incredible talk. And I see also Muthu's raised hand. So yeah, Muthu.
Yeah, hi, Lauren. This is a nice presentation, by the way. So I would like to know, this is a technical question. I would like to know whether you have you tried solving some heat flow equations like 1D. People when talk about solving partial differential equations, they try to attempt solve 1D heat flow equations, 2D heat flow equations, which are, I think, linear in nature, at least, which can be solved. You can analytically solve and obtain solutions. Have you tried solving those equations and benchmark your results against classical solver? And also, second question is like you mentioned that this is hybrid solver, right? Like some of the parts of the algorithm is classical and some of them are quantum actually. So I would like to know what are the ratios actually, like how much of them are quantum and how much of them are like classical.
So very briefly, because I don't think we have that much time, but basically for the first question, yes, we solve other equation. We've done a press release on our work. If you look at Colibri Quantum, you can search on the news. We just did a press release on our work with the Heron 2 QPUs, 156 qubits on Euler equations. So that's one, but we could present more of the partial differential equation we solve. The second question was about, can you repeat the second question? Sorry.
I would like to know how much of the code is actually
So we are using a
quantum and
VQA algorithm. So the classical part is for the optimization of the circuits to build the ansatz.
okay.
So I would say it's kind of, it depends, but it's kind of 50-50 because a lot of work we do is on optimizing the cost function estimation on the classical hardware.
Okay, thank you.
Thank you. And I also see one more question in the YouTube comment section. Are you also using quantum emulation, e.g. GPUs?
So yeah, it's basically the Captiva, for example, as a GPU option. Yes, it enables us to get a little bit higher in terms of qubits number you can simulate, but with noise, it's pretty going down quite quickly. But yes, we can use GPUs for simulation when they are available.
Great, thank you. Thank you very much once again also for your talk. And yeah, I think that we can now move to our next speaker. So Alexandra Pinto from Xairos, who will be speaking on quantum time transfer using entangled photons for resilient PNT applications. Alexandra, over to you.
Great. Hopefully you can hear me and you see
Yes.
my screen.
So not yet, but I think that it will be soon visible.
Okay, then just give it a couple of seconds. Yeah, maybe I just start by saying thanks for inviting me again. It was 2 years ago that I already make a presentation here, but a lot has happened in these last 2 years, so hopefully I can show you a bit our progress.
Yeah. We can still not see your screen.
Okay, this is strange. It says your screen is being paused. Let me stop my video just in case of this bandwidth. Yeah, do you have idea what is happening?
I'm not sure, but
it says this is being paused. Maybe someone else has the rights for sharing the screen or something like that.
Let me check.
Share. This one you can see it?
Yes, yeah, we can see the screen now.
Okay. And do you see the presentation?
Yes.
Perfect. Yeah,
Thank
apologies.
You. No problem.
Sure, so let's go into the details. So just an agenda, I will start by giving you an executive summary. After that, I will explain why Xairos, what is our problem and solution statements, what is exactly our quantum time transfer dual use market, what is our current pipeline, and I will especially focus on a demonstration that we are building for the government in the Netherlands, and what is our current traction, and a small conclusion. So let me start by explaining you that Xairos is building a global critical timing infrastructure with exclusive quantum technology that is going in our satellites. With this technology, you will enable completely the capability of 6G networks. That means self-driving vehicles, the quantum internet. You can also build more efficient data centers and a more efficient power grid. Well, why is that we can do this? Basically, we are taking the most of quantum entangled photons to have a more accurate service compared to the current GPS radio frequency technology. We are 3,000 times more accurate. We are also more resilient given the properties of entangled photons. Our technology cannot be spoofed in comparison to GPS. It's also easy to go to market. It's ready to deploy because we are using commercial off-the-shelf hardware. That means we are using sources that have been built for quantum entanglement, quantum key distribution, sorry, and also the same detector, same hardware. Basically, we can use. It's also a deep mode. I don't know if you're familiar with this term, but that means it's pretty secure. The term quantum time transfer was invented by Xairos. It has been patented. It has trademarks around it, so it's easy to go to market with such an infrastructure. We also have a really good financial path. We have projected an acquisition by 2030 and around 1 billion. Our growth has been also quite good, quite stable. As I said, 2 years ago, I also presented for QBN. And back then, we only had a table, a test bed, like proof of concept, only 5 people. Today, we have 18 people. We have 3 offices, one in Colorado, in London, and at Delft, where I am currently located at the moment. So our growth is also quite good. We projected to keep it at this pace, so it's quite exciting. Our traction is also good. We have contracts already closed with US Space Force, Air Force, ESA, NASA, and others that I will mention later. Our funding has been up to date 2.4 million, and we have around 4.8 million in grants. And our market is really big. Surprisingly, the GPS market, if you want to change GPS receivers and the whole infrastructure when it comes to time distribution, the market is quite big. So it's pretty good. So why Xairos and why quantum time synchronization? This is important for every single person, I would say, every single industry, because we all rely on GPS signals for position, navigation, and timing, but it's a single point of failure for the whole world. So if GPS fails for even 1 hour, our whole economy suffers. And this is something that is well known since 20 years ago or more. If you see, these articles are like from 2016, but up to date, we still don't have a backup plan. And that's exactly what Xairos is building, this backup for GPS. And we have an advantage when you compare to radio frequency time transfer, that's like what we are using today, in comparison to quantum time transfer. So in the past or with GPS, you measure the offset in phase of radio frequency, and that only allows an accuracy of 40 nanoseconds. When you measure an offset of individual photons, you reach an accuracy of 10 picoseconds. It's also difficult to jam based on first principles of entangled photons. It's also unspoofable thanks to Bellsted's authentication of the timing source. So it's quite robust, especially for defense applications. But let me explain you also a little bit our positioning. If you distribute the market in terms of accuracy and security, what you can see here is that GPS for civilian services has not good accuracy, security, and it's also not good in terms of accuracy, or not good enough for urban environments and really the 6G network that we require today with all the AI going on and like the idea of having self-driving autonomous robots. So we really need to push in terms of accuracy. But perhaps for humans, we don't need picosecond accuracy, but for our electronics, we really do need the accuracy that Xairos is building. I also want to mention here China. Baidu is the kind of GPS for civilians that China has built. It has better security and better accuracy. So it's urgent that the Western world does something like Xairos to have a better infrastructure for civilian and for military purposes. Our commercial architecture looks like this. So what you have is one satellite above even the GPS network of satellites. You can go to a geo architecture, and then that is where you place our satellite with quantum hardware on it. After this, you also have to connect that satellite with optical ground stations. Those are the blue dots that you see here in the ground. We also build those optical ground stations. They are already, in this year, they are gonna be ready to buy if you are interested. And we also need a last mile fiber timing synchronization that connects those optical ground stations with the Internet of Things or data centers or any other kind of use application. Something that I want to mention here is sometimes people say that it's not necessary to have too much accuracy because they see it in terms of time. But if you see it in terms of space, you also get less than 1 centimeter accuracy. And that's what you need to locate autonomous driving cars, for example, in an urban environment. Here I can also just briefly mention that current radio frequency from GPS is good for mobile applications, but for fixed sites and really urban environments where we all experience that GPS is not working good, the Xairos service is going to be really, really good. This is to measure why this is a dual use. So it's not only for military purposes that you want like a really robust and accurate timing service. It's also for scientific, power grids, telcos, data centers, and financial transactions. And as I already mentioned, the market is really big, $460 billion is estimated. And let me just zoom in a little bit more into the scientific applications, since we all love quantum, and we are here to talk about defense also. So I will just dig into these two, military and scientific. But for now, with a better or more accurate quantum timings synchronization, you can also have quantum networks really communicating between Barcelona and Chicago, for example. You need a global service, not just a small synchronization between Europe. You also need to synchronize the whole world, and for that you need always a satellite. Also, outside Earth, if you want very long baseline interferometry, you also need something really accurate like Xairos. Now we have a really good market opportunity. This is our beachhead established. It's all the defense and military, scientific, and power grids. We already have contracts with them on around 4 million. And our early adopters are already also identified, and we already have really good conversations with them. Meta, NVIDIA, it's pretty well known that if you have better synchronization in data centers, you make them more efficient. So it's really good for sustainability aspects also. We have also two divisions in the market. First, we are in the stage where we have not launched our satellite. So we can offer a service that is terrestrial, but it's pretty good for government, for study phases, and for telecom and data centers. As I mentioned, you can generate a lot of efficiency when it comes to synchronizing more accurately for data centers. But after we launch our satellite, which we expect to happen next year, we will provide a completely new market. That is like when you have distributed data centers problems, when a data center is in Australia and the other one is in US, and you want to synchronize them, then you really need a satellite. Yeah, so this is a bit our pipeline so far. So up until now, we used the seed funds to build our QTT proof of concept. We also have running projects that are paying for our terminal, quantum plus optical terminals and quantum plus optical ground stations. Those are going to be ready by the end of this year, and then you can already buy them. Next year, after our Series A funding, we will do a demo satellite to provide a regional service, let's say just synchronizing Europe, for example. And after Series B funds, we can have a global service like synchronize Europe with US, for example. These are a bit the projects that I want to discuss. I will just dig into the European ones that maybe are of mainly of your interest. And those are with the European Space Agency. One project was with Inmarsat and Heriot-Watt University, where we developed a simulation model and a commercialization plan to run those in a payload on our satellite. Also with the Greek optical ground stations, we work with Riometrics and Skylabs, where we build a quantum receiver for large fixed optical ground stations. Now, Europe has been really instrumental in maturing our technology. We jump from a proof of concept to building a real demonstrator together with TNO in a project. TNO is a research institution in the Netherlands, where we run, it's called Kicker. With this project, we work with other companies building a demo where we had a free space demonstration of around 100 meters. Now we are working together with Cubitrium and QDev. This is the project I want to dig in a little bit more. Where we are also building a free space demonstrator with enhanced security. Yeah, and we are working towards a portable demo kit that will also help to do these demonstrations. So what we are building in the Netherlands is a quantum secure timing and communication that can be rapidly deployed in radio frequency where GPS is denied. So that's basically at the front line. And our mission is to make our system as small as possible so that you can carry it in a drone. And as rapidly, like it really needs to be portable so that you can like added into I don't know, a military needs to use it really quickly. So it has to be portable and rapidly deployed. On the security aspect, is going to be quite robust. At the end of this project, you will have a basic security analysis, but also designing countermeasurements. Like, for example, if you find any risk in our hardware, you can also have some countermeasurements, and also demonstrate resilience to basic delay and relay attacks. So with this, the idea is that each one of these components that are part of our demonstrator is going to be really small, the smallest in the market, thanks to our consortium with Cubitrium. They build really small entangled photon source detectors, and they are aerospace qualified. So we can add our algorithms into that hardware and put it really on a satellite or on a drone. This is a bit like a list of our partners and customers. I just want to mention here QBN. We are really thankful with the support so far in the last 2 years. I think we have been members. It has been really good to find suppliers. We are constantly looking for European suppliers to run our European projects, of course. So QBN has always been really good for this. And let me finish with a conclusion really fast, just to mention that the perception of time it has always been subjective, as you well know. It's not only subjective to our perception as humans, but also as our measurement and our technology evolve over time. So quantum technologies are this kind of measurement opportunity that we have to evolve the way that we measure time. Thank you so much.
Thank you very much, Alexandra, for this interesting and insightful presentation. I don't see any questions in the comment box, so is there any question maybe from the panelists here? Yes, Muthu?
Yeah, sorry. Hi, Alexandra. Really nice presentation. So I would like to know why entangled photons, discrete photons, why not continuous source of photons? Like people do this as well, right? Like you can use squeeze light to improve the accuracy of your sensor, where you can tune some parameters and you can tune your accuracy as well. I would like to know from that perspective why use entangled photons, because I think both of them are like very hard to control in experimental setup, if I'm not wrong. But why the specific candidate, like Bell states?
Yeah, for sure. This is it was patented by the founders of the company, so I can just refer to that patent. It was selected like this because the fact that it's hard to control it also makes it really hard to spoof. So that's the only way that you can really detect that nobody, like there is no eavesdropping in the middle. So as far as I know, that's the only way, but I'm sure like the scientists inside Xairos will always dig in deeper to see if there are ways around that could be easier. But so far, that's the state of the art. You really need entangled sources.
Okay. One less technical question, like has this accuracy that you're mentioning in the slides has already been realized? I mean, the quantum advantage that you are showing?
Yes, for sure. We already have a proof of concept, and we also did a demonstration at TNO and inside the Space Force and US Space Force. So yeah, it has been already proved.
Okay, great. Thank you.
Thank you. And I see Matt also has his hand raised.
Alexandra, great talk, really fascinating. You talked about the system being secure against spoofing, whereas jamming is actually a more significant issue at the moment of GPS systems. Has it got any kind of resilience to that at all?
I didn't understand the question.
So you talked a lot about being protected against spoofing for GPS or navigation, but jamming is a more an issue right now that's happening. Does your system provide any resilience against jamming?
Yes, it's both. I think I mentioned it in my slides. It's like you have the like entangled photons give you those two added values, like it's unjammable and it's unspoofable. So that's both have been proved. Yes.
Would you just shine a really bright laser at your receivers?
Yes, exactly. Yes, it's quite a bright source, that's for sure.
But can you filter out within that bright source at all?
Well, there are some filters that you need when it comes to atmospheric effects and all this kind of noises from the environment, but it's still a bright source.
Okay.
Yeah.
Thank you very much for these questions. I don't see any more in the comment section, so we can move to our next speaker. Thank you, Alexandra, very much for your presentation. So yeah, our next speaker is Matt Himsworth, Chief Scientific Officer at Aquark Technologies, who will also discuss the opportunities and challenges in sensing and timing with cold atoms, an area pushing the frontiers of precision technology. So Matt, over to you.
Thank you very much. Just check on technical things. Can you see my slides?
Yes.
Okay. Have you got the slide screen and not the information screen that I've got? It usually gets mixed up.
Actually, I see. I think we see your screen, but not the actual presentation. So.
On that now.
Yeah.
No presentation.
Yes, we see it, but yeah, you need to click on the slideshow because we see.
It's just showing me we're on this screen. That's right. I'll just go back to.
Yeah.
Can you see that? The
Yes.
PowerPoint.
Yeah, we see. I think in any case, you should click on the slideshow so that we see the full slides.
And I did, but it came to stop that. So we'll just head off with this, I think, for the moment, if that's okay.
Oh, okay. Yeah, I think
I'll
it
try
should be
again,
fine.
but if I do that, it will. You don't see anything, I guess.
Yeah.
Yeah, sorry, it's a multi-screen computer, so it's a bit playable. I'll just go along with this.
Yeah.
Thank you for inviting me to talk and your support from the network. My name is Matt Himsworth. I'm from Aquark Technologies. My background is I've been in quantum tech for the last 20 years. I spent 10 years of that in university research, where a lot of the technology we can talk about today were developed. And then I went and worked for the Ministry of Defence, helping build up their labs and internal research for 5 years before joining Aquark. So the background behind Aquark is, yes, it was founded around 2010 in my research group. We looked at kind of miniaturizing cold atom systems, mainly miniaturizing the vacuum cells that are involved. Along that way, we discovered a thing called a supermolasses trap, which I'll talk about in a bit more detail later. And that's kind of one of the backbone technologies that we have in the company. That's the point where I left academia. One of my postdocs set up a company along with Andre Dragomir, along with his person called Alexander Janssen. They set up the company using the IP from the research group and thought there was some worthwhile technology there that could actually move this stuff out of the lab. They went through a series of accelerators. We won a UK Innovate grant to build an atomic clock, which I'll talk about. We've done lots of firsts. One was putting a cold atom system on a drone and operating it continuously in quite harsh environments. We also then went through a Diana accelerator, and we were one of the first quantum company that got invested by the NATO Investment Fund. And this is where we are at this moment. The company's grown. We've been going for 4 years now. It started off with 2 or 3 people. We're now at 14 and we'll be growing over the few months, aiming for about 30 in the next year or so. We have a number of nationalities all across Europe. Very proud of having that, and a good mix of physicists, but also engineers, mathematicians, and business developers. So our company works on the basis that we think neutral atoms are a key kind of qubit or quantum system that could be the most useful, or at least the most versatile. There's lots of obviously other choices such as ions, photons, and superconducting qubits, for example. They all are useful in their own fields, but we want to work on a technology that we can move out of the lab properly, make the hardware to make that happen, and make a system that can generate cold atom systems for anyone at any time, and they can integrate into their system. Cold atoms are, we think they're kind of one of the kind of strongest quantum systems you can get. We're talking about individual atoms that are well confined and separated from the environment. You can control them with laser beams. You can demonstrate nearly all the sensing systems. You can do computing, of course, as well with that. The laser technology is very straightforward, and there's a lot of common subsystems, electro-optic systems, electronics, detectors that are common to actually across the whole area. So I think if we can work on miniaturizing and integrating cold atom systems, we can actually address a whole range of applications. And we're trying to be as application agnostic as possible. I'll just move on. So what can you sense? I mean, we are a sensing and timing company. We don't do anything on computing. Doesn't mean we can't or won't in the future, but we're focusing on sensing and timing because this is technology you can have right now. It's been developed in the lab, demonstrated outside the lab many times. That technology is ready. It's already pushing the state of the art. It's already beating classical systems. The main kind of 4 areas in terms of sensing it can pick up is magnetometry, where you're, from a little cartoon there, you're picking up the different orbits of the electron around an atom and how that interacts with the light going through it. These are some of the most sensitive detectors in the world, and you can work with either cold vapors or warm vapors for that. Time and frequency, of course, time is the original quantum technology, the atomic clock. It's still pushing forward every day. I think some of the most sensitive clocks in the world can measure the clock moving up by about 1 millimeter in terms of the gravitational, the general relativity redshift on the system. They're that incredibly sensitive now. And also when you measure time, you also measure frequency, very important across a huge amount of sectors. Things like inertia, we essentially drop our atoms, look at how they move through an optical field. From that, we can measure motions, rotations, we can measure gravity, we can look under the ground on Earth, looking at gravity, which might have very important application in things like civil engineering, when you want to dig holes or look what's under the ground, or you want to look for minerals or other kind of precious materials underground, or even just geophysics, basic science, lots of applications. Inertia, well, that's your navigation. If you don't have GPS, you're going to be relying on inertial navigation. So that's measuring your movements and rotations. If atoms can measure that, they can measure gravity, they can measure accelerations. And lastly is electrometry, or you might hear it as electric field sensing, DC or RF fields. There are incredible kind of interesting ways of doing that, measuring the effect on very high orbits in atoms, where you can have extremely wide broadband antennas, which are really exciting technology. It's measuring RF fields with optical fields via atoms. It's a fascinating world. So there's a huge amount of applications. The sensing industry is huge as well. And what quantum can bring to that is you can bring higher performance. It can bring more reliable results. So the measurements you're making are based on fundamental physics. They do not change in time. They do not change from point to point. So they are essentially calibrated forever. And then you can add enhancements in strange effects like entanglement, where you can get enhanced filtering techniques and distributed sensing as well. So it's way more tools for the engineer to play with when they're building sensors. For Aquark, we're a very small company at the moment. We're building up, so we have to focus in some areas. Our core technology is making the cold atom system miniature and integrated as small as possible. That is our focus in our system, but we have to build the market, we have to build applications, we have to build confidence. So we're looking at some areas in which we want to show some demonstrators. One is time. That's our initial one because that's the most straightforward thing. In terms of sensing, I imagine clocks as being an anti-sensor. You're trying to remove every kind of sensitivity to the environment as possible. If you can do that, then you can start adding in your sensitivity back in with very high performance. Gravity is another interesting area so we're dropping atoms, that we're slowly building that area up. But I'm mainly going to talk about time today. So where is that important? Well, there's huge amounts of areas. I think Alexandra has very clearly explained how important time and time distribution is across a whole amount of areas. We've talked about telecoms, of course, the movement to 5G and 6G. That's going to require much better timing. Let's say, Alexandra, you probably need some good clocks on your satellite, so yeah, get in touch for that. Finance and engineering, aerospace and defense, which is obviously the focus of today. GPS is a series of clocks all the way around the world, talking to each other and talking to you. If you can improve the quality of those clocks, you can improve the timing and the positioning of your system. So we need clocks everywhere. So why do we focus on defense and space? So in the end, we want to have a commercially successful company that's making lots of money, making several products. The commercial drivers really here are, we want things to be low cost, we want to make high numbers, we want to have a huge market to move into, we want to have lots of features, but that's really hard to start off with. That's especially if the market is very, very small, amount of awareness of the technology is small. So it's hard to jump straight in there. And that's where a lot of companies die, because the valley of death is that hard point of, we've got this great technology, the market's not ready, how do we fill in the bit in between? And so this is where defense and space can come in, because they are looking for specialty projects. So they're only looking at very small numbers of things, but they're willing to pay prices for that. If they can get a new capability, the money is there to pay for that. And in building that up, building up that, say, space and defense kind of support and reliability and proving that the technology really works, you build up a huge amount of areas that are really important for that commercial success in the end. So things like reducing size, weight, and power, improving autonomy, robustness, how you manufacture these things, how you can increase the scale. So what I want to say is that defense and space are really important sectors to support those emerging technologies, building that reliability of that hardware, so then it's ready to enter the commercial market in a few years' time. So one of the challenges of space and defense is it's got to sit in a rocket or sit in a tank or whatever kind of like defense platform you've got there. They are not nasty. They are not very nice environments. Space, of course, the thing's going to be strapped to a rocket and be shaken. In defense, it's going to be kicked by a soldier quite regularly. My background in defense, I knew that's a thing we really worried about quite a bit. So we really, as a company, we push getting our technology out there, even when it's not completely ready. We want to go and experience sticking it out in the real world and learning how it fails or doesn't fail in interesting ways. We put these things onto Royal Navy boats to show that they work. There's a picture on the top left there with it right next to the engine room, working very merrily. We put them on drones in near freezing environments. And we had an interesting, I think how Elon Musk calls it, a rapid unexpected disassembly. And when the drone blades broke and it fell 100 feet, hit the ground with over 17 G. The only thing that broke in it was an optical fiber. So we replaced that and the system worked within 5 minutes again. It operated continuously for 2 hours up in the sky. We've also put some of the subcomponents on vibration tables. So the top right there is a laser spectroscopy unit that vibrated to a simulated rocket launch, and you could not see on the aero signal. It was very stable. On the bottom right, we put it through magnetic field testing. We've also done things like environmental chambers for temperature and humidity for various components. So we really want to learn how to get this stuff out of the lab and put our money where our mouth is. We're also looking at miniaturization. So the left-hand side image here is our kind of benchtop demonstrator being lifted by the two founders of the company back in 2022. Very short runtime, quite a large system and heavy. That went onto the drone a year later, much smaller, much more compact, longer runtime. Last year at the showcase, Quantum Showcase in the UK, we showed off a much smaller system, about the size of a toaster, continuously ran for the whole showcase all day, much lighter, run off simple battery power. Much more atoms in our system, more robust and reliable. You can shake that as much as you want and the atoms stay put. And we're going to try and string that even further because we're trying to make a system that fits inside other systems. So the smaller it is, the better it is, the more it could be protected, the more it could be, the more functions you can have. And finally, our future one is, can we put this on a chip? Can we make this integrated into a photonic integrated chip or electronic system or hybrid kind of technology? And then it's just like a hard drive card, you slot to your system and then you have cold atoms. How can we do that? We have some really interesting IP. One of them is the supermolasses trap, which is a way of laser cooling atoms from a vapor, directly from a vapor, into the trap without any magnetic fields. So the last 40 years, the main technique has been the magneto-optical trap. Everyone uses. This one is a supermolasses trap, requires slightly different technology. What comes with that is lower power requirements, much higher stability. We've done some measurements, and it's about 10 times more stable than equivalent kind of single beam systems or in the lab. We have other technologies such that we've kind of borrowed techniques from the microfabrication industry and the materials there to make these things smaller, more lightweight, more mass producible. We're aiming towards making passive ultra-high vacuum systems, so no longer our vacuum systems need to be powered. Doesn't require ion pumps which produce magnetic fields which affect your measurement, make the system overall bigger. This is our main focus over the next 5 to 10 years. As I promised earlier, we have been making a clock. This is the UK's first cold atom atomic clock. It has a supermolasses trap in there running at about 10 hertz. We measured the atoms via coherent population trapping. It has dimensions and power requirements similar to industry standards. Has also internal holdover capabilities for an hour. We've designed and built this whole system from scratch. None of us knew how to make atomic clocks from the beginning within 18 months. It has already been out of the lab in various real-world environments. So we like to put our money where our mouth is. It's going out and being tested, put it through its paces, and it's performed wonderfully through all of those. And we have future ones that we're moving on here. We want to make this much smaller. We want to make it much higher performance than we have at the moment. I'll give you a hint of how well it's working at the moment. And we want to make it cheaper. The problem is atomic clocks are expensive. They are high-end supercar kind of level prices. If you want to put them in telecoms towers, they have to be a factor of 2 or 3, maybe 4 times cheaper than that. So we're going to be looking at making our system simpler, more easy to manufacture, and more mass producible and cheaper, hopefully. Performance so far, this is the system. So this is one of the rare occasions that the AI image that we generated right at the beginning actually looks somewhat like the real thing without the red fancy lights on it. This is our first measurement we ever made. It's good, it's not the greatest. This is the first time we actually got to see how good it's going to be. We're now going through the next year of getting that better and better, higher performance, lowering it down. We're trying to get to the 10 to the 14 at long timescales, if possible, which should be possible. There are other people have demonstrated similar performance, so we can get there. Albeit in the lab, they don't in the lab, we're going to try to do it in this kind of compact system. And that's the end of my talk. Have we got any questions?
Thank you very much for your insightful presentation. I don't see any question in the comment box. Does anyone from our panelists have a question, maybe? Yeah, Muthu?
Yeah, Matt, really extraordinary work and nice presentation. I would like to know why in recent days, like 5 years ago, people were doing sensing, gravimetry, making atomic clocks using ions actually. And I can see that many of the research groups are moving towards neutral atoms. Why is that the case? Any specific reason?
So it's actually an interesting demonstration of quantum physics. With ions, you can trap a single ion for a long period of time. So you're talking, at the best, they could be weeks long. Whereas the atoms, you may only have for a second or so in your trap. But
they achieved for months now, actually.
Sorry?
With ion traps, you can even maintain the coherence for months.
Oh. Yeah, so and you're still measuring the same thing. You're measuring atomic states within those elements.
Yeah.
But with an ion, you're measuring the state once every time. You have to reset your system and measure it again. Of course, quantum mechanics, each measurement, there is some uncertainty in that measurement. And so therefore, you have to repeat your experiment thousands of times, in which you then basically start solving the Schrodinger equation, and your expectation value from that is your result. With the neutral atoms, you're doing 1 million measurements per measurement, because you have 1 million neutral atoms, all independent from each other, not affecting it. So that means that each measurement is more, your uncertainty drops considerably. Now, they don't exactly balance out exactly like that, but also with neutral atoms, because you haven't got that electric field sensitivity, you're far less sensitive to your environment, right? You actually, the magnetic field, the electric field sensitivity is thousands of times, millions of times lower. And so therefore, the actual effort in an atomic clock is not to do the measurement, it's to prevent the environment affecting your measurement. So I showed you that plot. That's our first attempt. A lot of it now is improving that, with shielding and how you control and measure the atoms. So that's generally more straightforward with numerical atoms.
Okay. Second question, from the application side, when you talk about electrometry, you said that you can measure dipole moments, right? So which order are we talking about? Can you measure proton, like electron dipole moments?
So
it's of order around 10 power minus 14 joules per Tesla, I guess. Like, what are the scales are we talking about?
So the main technique that's used for measuring those fields with neutral atoms is Rydberg receivers. So you're exciting the atom into like the 100th orbital, at which point it starts coupling into RF fields at that point, and your dipole moment is 4,000 times higher than it is on the ground state. And of course, you've got this manifold of energy levels there that can cover everything from very low frequencies, hundreds of megahertz, or even down to DC with certain techniques, all the way up to terahertz. So you've got this extremely wideband RF receiver, but it's also electrically small because it's a little vapor cell. It doesn't need to be the length of a standard classical antenna is defined by the wavelength you're measured. It can be very, very small, but that huge wideband, that's where everyone's looking at that kind of area as an area for growth, and with the potential of beating classical sensitivity as well. No one's reached it just yet, but the potential is there theoretically.
Nice, thank you.
Thank you very much for this interesting Q&A session. Since I don't see any further questions or hands raised, I think that we can definitely move to the next speaker. Thanks, Matt, for that deep dive into cold atom-based sensing. I'm glad to invite our next speaker, so Muthu Vetrivelan, Senior Quantum Engineer at Artificial Brain. He will present on quantum for defense and space, highlighting how these technologies are advancing capabilities and security. So yes, the floor is yours, Muthu.
Yeah, I hope you guys can see my screen now.
Yes.
Okay. Okay. Yeah. Hi everybody, and this is I thank QBN first for giving me an opportunity to present here on quantum for defense and national security, basically. So I'm Muthu Vetrivelan. I have a PhD in quantum technologies, and I'm working as a senior software engineer for Artificial Brain. We develop quantum optimization software, quantum machine learning, and also started working on Gen AI recently. We also have office in US, in Europe, in Netherlands, and as well as in India. Okay, so this is for people who have no idea about quantum computers, from the layman's understanding of quantum computers, basically. So what is we develop quantum algorithms that run on quantum computers. So what are quantum computer? What is quantum computing? It's a new way of doing computation, basically. So you have zeros and ones, and you encode your information into this binary digits, and you process information, and you get results, basically. In quantum, you do the same, but in quantum, you can additionally from zeros and ones, you can also have information encoded in a bit, which is, let's say, which can have a chance of 50% chance of being 0 and 50% chance of being 1. So this extra degrees of freedom of, in quantum, you can actually encode more information and process more information, basically, which are very good at solving complex problems. Currently, we have big companies like IBM, D-Wave, IonQ, Rigetti, even Google allow users to run their quantum algorithms on their hardware through cloud by paying them as some as a service. So what about the problem statement? So we are currently working on the problem statement is the war fighters actually face real-time operational scenarios, which involves billions of potential strategies basically. So we will convert this into optimization problem and we try to solve it classically, right? So when we talk about billions of strategies, we have billions of decision variables we try to optimize basically. So classical computing often struggles to solve this problem in a very short time, and also which is very needed for informed decision making. For an example, let's say you have 100 drones and you want to select 10 targets, factoring in different drone sizes, paths, and also you put additional constraints. Let's say that a particular path is not allowed, then this will yield actually 17 billion combinations approximately. So in order to solve these problems, dynamically optimize your drone routes are all very difficult actually. Using classical computing, we cannot do it in a very short time. We can use quantum computing to do that basically. So solution we are providing are using quantum computing to make this problem solving, in real time and dynamical, make it dynamic basically. So in artificial brain, we have multiple solutions for defense and space. So the first solution is being auto labeling of hyperspectral satellite images. So what are hyperspectral satellite images? Basically, these are satellite images taken by a specific special cameras called hyperspectral cameras, which captures the reflectance from the sunlight, which will have which will be in all electromagnetic spectral range, but it will capture the reflectance from ultraviolet to the infrared range actually in the electromagnetic spectrum. So what you're seeing here is a region where it contains slides, buildings, and some terrains, basically dirts. So you capture this image from satellite and you take the spectrum and you put it into one of the pixels corresponding to that region basically. And if you take flight, which is made up of metal, and buildings are made up of concrete, and dirt is basically, sand and other things. So each of them have different absorption and reflectance based on its chemical composition, right? So it will give you unique signature for each of these macros in the hyperspectral images. For example, in flight, you can see that it's different from buildings, and the dirt and roads are also very different. So we take this hyperspectral images, and auto labeling of this hyperspectral image is a very complex job actually, and there is no efficient software right now which utilizes classical machine learning, let's say, which is the state of our technology, cannot even do this complex task of labeling hyperspectral data so easily with a very good accuracy. And we developed a software using quantum machine learning. Basically, we use techniques like supervised machine learning techniques such as quantum vector machines, support vector machines, to find the targets from the non-target regions. And our algorithm also classical, and the part of algorithm, classical algorithm also auto label these pixels on the ground basically from the hyperspectral image. So the patent pending software automates this labeling process of hyperspectral data with a very less number of training data basically. Why we doing this? Because as I was mentioning, the classical machine learning techniques requires a lot of data to train to give you a result with reasonable accuracy. With quantum machine learning, we actually trained our model with just 20 hyperspectrum data, and we achieved an accuracy of more than 90%. So how can we do this now? Okay, we also developed a platform which is called a Plank. All you have to
I think that maybe Muthu is having some connection problems.
So, sorry, you cannot see my screen now?
Yes, we can see it now, but you are off for a
Okay.
few seconds.
Okay. Okay, I will go through again. So how can we do this? We have a software called Plank. All you have to do is you drag and drop your TIFF files, which is the satellite image. You can get it from NASA or from Italian websites such as Lazio. So this looks something like this on the right-hand side. So we picked a region which is called Airplane Boneyard in Tucson, Arizona, US, where you have decommissioned, US aircrafts lying on the open ground, basically. So when you drag, after you drag and drop your TIFF file, what you see is it will immediately create a heat map, which looks something like this, which can give you some idea about, the reflectances of the different objects in that region. But our ultimate objective is to find a target and to auto label, locate all the targets in that region with the less number of training points. I think, am I frozen? No, right? Sorry, am I frozen?
No, you're here.
Okay, sorry. Okay, so what you see is that our QML algorithm with 20 training points, you have to give 12 target regions and 8 non-targets. Why 12 and 8? We actually tried it with the different regions and different macros, let's say vegetation, also water bodies, urban areas, and we found that uh, from experience, we found that 12 points are actually enough to train the model really better. So we give 12 target regions and 8 non-target regions, and we also label the data with zeros and ones and trained our QSVM model. And once you've done that, and if you predict, make the predict for the region that of your interest, so it will do something like this, which is the binary map that you're seeing here. So the white pixels here are the regions that indicates the planes and jets, which are the decommissioned planes that I was talking about. And the red region and the black regions are the regions where you don't have any flights, basically. And we achieved more than 90% accuracy in this problem. And the second POC that we already have is satellite scheduling optimization problem. So what we do is, let's say you want to identify the combination of targets that maximizes mission impact in a war zone. Then let's say even if you want to take 400 targets out of 10,000, then it will create like a very large number of possibilities. Basically, it's astronomical, 10 power 727 in numbers. So solving this in real time is also very difficult. And we have shown that if you have those many decision variables, we can actually solve them with 39% increase in speed. And also the results that you're obtaining will be 24% better than the classical solvers, basically. So this will also help us, making the mission impact really, really better. So this optimization problem is already, the solution of the optimization problem is already benchmarked against classical results, and it is published in IEEE. And the results are also mentioned in an article in the World Economic Forum last year, as well as in Nature. And currently, we also started working on drone swarm optimization. Once again, if you have 100 drones and 10 targets, which will lead to billions of permutations. So dynamically, re-optimizing the drone path is very difficult with such number of permutations. We are building a quantum accelerated platform that can re-optimize this based on the allocations, really, really faster. Also, we are working on a platform, which is an optimization platform, again, which we call C3, command, control, and communications. Let's say that you have multiple assets across a land, air, and sea. So making a decision with all these assets simultaneously, it's very difficult. So with our quantum platform, optimization platform, we can integrate this C3 and make the asset coordination and planning really seamlessly and faster, basically. Runway utilization optimization. Again, we have during wartime on high tempo military operations, where you have a limited runway capacity, it will be very difficult to optimize, takeoff and landing schedules. So in that case, we can again use quantum optimization to make it really faster and better. And we also have a POC for secure communication, which is based on quantum homomorphic encryption. The idea is basically you take a classical, you have a server where you send a request to the client. So the request will be converted into a quantum state, and then it will be sent to a client where the client will perform certain actions on the quantum state that you have sent in. And after the action is being done from the client side, it will be sent back to your to the server, where the server decrypts the information and see what kind of possible actions are taken by the client, basically. So this is a very secure way of doing encryption, because the quantum state that you are preparing cannot be cloned because of the fundamental theorem in quantum mechanics, no cloning theorem. Also, if there is an eavesdropper in between trying to steal your information, he will do certain actions. Technically, it's called measurements. So if an eavesdropper does some measurement on the quantum state and it will be sent back to the server back, then he will know that there are some additional measurements or actions has been done on the state that you are trying to securely communicate with the client. And he will know that, he or she will know that the secure communication has been already compromised. So we already have a POC on this, and the use is that you can, this is like a, you can make a very secure communication for sensitive systems, which can, which are actually a threat against next generation cyber technologies. And you can also deploy it in satellite links, multi-domain operations, and also you can also allow, trusted results from untrusted nodes, basically. So all the use cases that I was talking about have dual use. We have potential customers on the commercial side as well as from the defense side. And the target market size for the optimization ideas that we have, POCs, we have, in the starts from like 40 to 90 million in the early evangelist regime to expect to grow 125 billion in the total addressable market, basically. And about the team, we have our founder and CEO, Jitesh Lalwani, who has 15 plus years of experience in software industry. And we have Dana Lynette, who's our senior executive. She has 30 years experience in defense and aerospace. She's a retired US diplomat and former Lockheed Martin aerospace executive. We also have experienced quantum engineers and 3 PhDs currently now, including me, and also a sales consultant. We also have advisors in quantum space and commercial growth. And last year, we pitched some of our ideas in the US Defense Accelerator Hustle program, co-sponsored by Air Force Research Laboratory, National Grid. And we won 100K actually in the funding round. And finally, we have partners from the government agencies, Netherlands, USPA, DRDC Canada, and Division of Science and Technology, New York State. And also we have institution partners like Griffith Institute in New York, University of Chicago, as well as special mention QBN. And we also have tie-ups with quantum companies which provide a quantum hardware as a solution service, So such as D-Wave, Quantum Inspire, and also we have tie-up with financial institutions like Creed and Bar. Yeah, and once again, I thank you all, QBN, especially for giving me an opportunity to present here, and I'm happy to receive questions.
Thank you very much, Muthu, for connecting the broader picture of quantum strategic importance in defense and space. Very clear presentations. So yeah, I would invite everyone to really ask their questions. There are no questions in the comment boxes. So does anyone from our panelists have a question? Yes, Laurent?
I have a question. What is a part of pure quantum and what is a part of quantum inspired part of your algorithm? Oh, I think Muthu is frozen.
Yes, maybe. Let's wait a few seconds. I think he should be back. If not, we'll have to move to the next speaker, but let's just wait a few more seconds. Yeah, he's here, but you're on mute, Muthu.
Still on mute.
I
Yeah.
got cut out, sorry, because of the bad internet here. I got your question. So there are two things. One is the optimization problems I've been talking about. It's completely quantum. We use annealers to solve those optimizations problems basically. And about the QML part I was talking about. So if we calculate this kernels when we talk about quantum support vector machine, it's something like VKU that you do, right? You have a cost function, and once you calculated the cost function using Ising Hamiltonian and the efficient ansatz that you make, then you use classical optimizer to find the local minima, basically. So similarly, we calculate something called a quantum kernel, which is nothing but the convolution between two states where you encode, future engineer your data into the actual quantum states. So you calculate this quantum kernel, which gives you a better results compared to classical kernel. Once you've done that, the fitting, everything is done by classical algorithm. So that part is classical, but you still use the quantum kernel to, find a line between which are ones and which are zeros, basically.
Are there any further questions for Muthu? Don't see any more raised hands. So then we can move to the next speaker. Thank you, Muthu, for your insightful presentation. Very, very interesting indeed. And if anyone else has any questions, they can reach out to you directly. So now I'm pleased to welcome our last but not least speaker, Tommaso Occhipinti, the co-founder and CEO of QTI. Tommaso will explore quantum communications for defense and space, which is a crucial topic as secure communication becomes really more essential than ever. So Tommaso, the stage is yours.
Thank you. Thank you very much. Do you hear me?
Yes.
Let me share the screen. Do you also see my screen?
Yes, we can see the screen.
Okay, perfect. So thanks again. Let us speak about quantum communication, in particular quantum secure communication for the field of defense and space. I am the CEO of this company that is called Quantum Telecommunication Italy. Just I would like to introduce the company very briefly. We are, we were born in 2020 as an official spin-off of the National Research Council in Italy, in particular of the Institute of Optics and Photonics, with 20 years experience regarding optical communications and quantum communications. After 1 year of history, we received the first seed, the first investment of an industry in our company. which is Telsi, a control company by TIM. TIM is the largest telecom operator in Italy, one of the largest TLC company around the world. So together with them, we are developing quantum secure networks, in particular quantum key distribution applications that are really ready for the TLC market. And we think that with this kind of knowledge, we can approach also the topic of defense and space applications. Right now, we are almost 40 persons, and we are based in two places in Italy, in Florence, where there are the headquarters, and in Rome as a business development office. I don't want to annoy too much everyone, you guys, about the introduction, since the previous speaker already shown many of the big important topics regarding the quantum revolutions and what we can do with the qubit, with the properties of quantum mechanics. So, and also this is really too easy, I mean, to show to everybody. So I go directly to the fact that with the use of quantum states, in particular single photons, we can do not only sensing and all the other application that has been shown previously today, but also you can do quantum key distribution, which is essentially a physical way of creating symmetric keys in two different places connected by a quantum channel. With quantum channel, we mean any kind of transmission channel where our quantum states can travel. So the perfect quantum channel for a TLC operator is the optical fiber. So of course our typical application and what we are selling right now all around the world is the QKD based on optical fibers that are already used for classical communication. So we can work in fibers where there's already the classical traffic, okay? But also, we will see later, we are working in the free space domain, and in particular, opening us the opportunities to work in the space sector. Let me just introduce another topic, which is really important. To whom is not so familiar on the security topics, we have to say that the security in the modern communication is essentially very related to the transmission or to the creation of keys between the parties. The possibilities are essentially two right now. So the conventional key distribution that can be used using, conventional mathematical algorithms, and the way of doing with the quantum mechanics, which is quantum key distribution. On the topic of the conventional key distribution, so the one related to mathematical algorithms, we have to point out that there are some interesting evolution on the algorithms that are called post-quantum cryptography algorithms that enable let's say, the security of the transmission, also with not only with I mean also in the case of the arrival of the quantum computer in the market. I mean, these are really two different approaches. I try to be more precise. The post-quantum algorithms, so the mathematical algorithms, are essentially a possibility to be safe against a quantum computer, while quantum key distribution is absolutely secure in terms of the rules of nature, in terms of the fact that we can call the quantum key distribution a non-conditional security, an unconditional secure method to create keys between the parties. We will see that we are working on both the topics, let's say. But before doing that, I will show you something that we have done on Earth. So here we have some slides just showing that QKD systems are well known and have been not only demonstrated but also sold. So we are speaking about the TRL 9 around Europe and around the world. In particular, here you see our product that is called Qualex, the purple unit appliance in the bottom of the slide. And using that product, we succeeded in creating the first international quantum network between three nations. It was done during the G20 in Trieste, connecting Trieste to Rijeka and to Ljubljana. You can see also that since there was no direct connection, direct fiber connection between Trieste and Ljubljana, we also introduced the so-called trusted node in the between the two cities, in particular in the city of Postumia. We were using a system that was really in a demanding environment. In particular, we were applying this kind of things in links up to 30 dB of attenuation, which is quite a big number for this kind of applications. We have done something similar, let's say more complex, during the G7, so very, last June in Apulia, in Italy, where we essentially developed another trusted node network between two cities, in particular the place where the big of the planet were speaking during the G7, and the Barifiera, where there were all the journalists and all the editors of the information that the big guys over there were discussing. So we were passing through Monopoli, another beautiful city in the south of Italy, and you see how complex was the system, but it was really effective. And we were working in WDM, for example, so sharing the quantum channel between our single photons with also the conventional optical communication channel. We have done something similar also in Lisbon recently. This one was really interesting because, first of all, we were asked by the organization of a UKTC to make something even complex. In particular, you see, we were making the connection through a very long optical fibers under the water. So again, enlarging the possibility of applying QKD not only on Earth but also above the seas in underwater fiber connection. We were also testing, and this is interesting, in my opinion, these kind of things during an experimental demonstration Gate Week event organized by the NATO forces in Yuma. And again, here we were showing our capabilities with our products. I switch on another field of application that is very related to defense, showing that we are working in an Italian research program financed by the Italian Navy, where we are applying quantum key distribution not only, I mean, not in optical fibers, but directly in free space and in a very difficult free space under the water. So this is something could be something strange, but very useful for some application of the Italian Navy. So you see that the idea here is to instaurate, to create a quantum link between a big submarine and an automatic vehicle or a drone under the water. Speaking about space, we have to say that quantum key distribution, generally speaking, has a lower TRL in comparison to what we have seen in my previous slide. This is, of course, because the environment over there is more difficult, and there are some topics that are really demanding, and also the cost of the application are much higher. The very interesting point here to outline is that some very clever Chinese made in the past a very beautiful example of quantum key distribution installation between Europe and China. And this was several years ago. But the funny thing is that really 2 or 3 weeks ago, they made another beautiful example of quantum key distribution, again with the satellite that they placed in orbit with the capabilities of transmitting quantum states. We think that to do quantum key distribution in a great way, we have to collaborate, we have to work really together, at least in the NATO sector, in order at least to be, let's say, at the same level or better than what they have done, the Chinese. What is doing Europe regarding the topic of quantum key distribution in space? We have to say that they have the super huge project that is called the Iris Square. That is a very important project regarding secure connectivity, and that Iris Square have a QKD subtopic inside. I mean, in the big project. Also, EuroQCI, so the European Quantum Communication Infrastructure Project, as the topic of making hybrid network between optical fiber quantum key distribution and space quantum key distribution. And I would like to outline also the SAGA project, the security and cryptographic mission of the European Space Agency that is really working on quantum communication. What we are, as a company, as QTI, are pushing here, we think that we have the right expertise to deploy ground-based QKD, in particular to create the so-called trusting nodes between the satellite constellation or the satellite communication and the ground segment, making hybrid quantum key distribution between the two segments. And we have also much expertise in the free space QKD links because of our expertise in subtopics that are really important to establish quantum links, in particular adaptive optics, active optics, and the aiming and aiming and systems for satellite tracking. I would like to conclude my presentation showing that we are working also in a city environment in order to create quantum key distribution links. In particular, these pictures are related to the city of Florence, where we are experimenting our quantum key distribution over the air. Here, I would like to outline the fact that we believe a lot on the so-called time-being encoding because I didn't mention, but quantum key distribution can be done in many ways, in many typical, let's say, technological ways. We are expert of time-being encoding, and we want and we are using it in our systems for fiber optics, and we believe that these are the right way of doing QKD also for free space applications. And I thank you.
Thank you very much for this interesting presentation. I see one question in the comment box. So can you please elaborate more on your specific USPs? There are other competitors, like for example, IDQ, who have achieved similar achievements quite a while ago.
I missed the initial part of the question, sorry.
So can you please elaborate more on your specific USPs?
Probably is referring to our specific technology compared to other competitors. Yes, we are, let's say, similar to the company that has been cited, so ID Quantique. We are using BB84 with time-being encoding. And this is quite similar to ID Quantique. There are other competitors that are using polarization, for example, and we think that that kind of technology to encode the quantum states is not so, let's say, optimal for what we have in mind. Maybe it's good for free space, but for fiber optical communication, strategical optical communication and fibers, we think that our technology is much better. What I missed to say because of, let's say, lack of time about my presentation is the fact that we believe a lot on the hybridization of the technologies, in the sense that apart the creation of the quantum key links, the quantum key distribution links, these kind of keys must be shared with the users of these secure keys. And to do that, we have other kind of apparatuses, other kind of appliances that are essentially key management entities. And in this, we differentiate a lot also compared to other competitor of us, because we can manage a very complex network, mesh network. So we are ready to time variant mesh network of QKD links with the system that are controlled also by software-defined network appliances and controller and orchestrators.
Thank you for this insightful answer. Are there any other questions, also maybe from our panelists? I don't see any hand raised, so yeah, there are also not any more questions in the comment box. So thank you, Tommaso, for this comprehensive overview.
Thank you.
Yeah, very, very interesting. I would like to thank everyone who joined us today, and also really a special thanks to our distinguished speakers for sharing their expertise on this important and interesting topic. It's clear that quantum technologies are playing a vital role basically in advancing defense and space capabilities. And we really hope you found this session valuable and interesting. If you'd like to stay connected and be informed about future sessions, please make sure to subscribe to our YouTube channel and also follow us on social media. So on behalf of the Quantum Business Network, I would like to say that we look forward to seeing you at our upcoming events. And until then, stay curious and again, follow us on social media, also on our website for more interesting quantum news. Thank you very much, and I wish everyone a wonderful afternoon.